Okay, let's get started. Okay, looks like everybody has a seat. That's great. I'm afraid that people may still. Anyway, okay, so I need to check with admin again with the current status of wait list. But hopefully, like with people dropping the class, we may still accommodate most of the students. And also, I'm checking with admin about the possibility of opening up a little bit for the distance section. So again, I'm monitoring this, and we'll see what we can do. Okay. So homework one, so the plan is to post the first homework this Thursday. Okay, so generally the procedure or the agenda will be like, we post on Thursday before class, and it's due in 1 week. So that means it will be due the week, so the following week, again, before the next Thursday class. Okay, and all the submission will be online. Okay, so make sure that you check the our Moodle website. So like to check the description of the homework, and also like make sure you submit online. So with all the submissions that I'm asking you to include your student name, student ID on the code of pledge. Okay, this is digital. Just all you need is a copy down that file or that sentence stating that you did not violate on the code of pledge. Okay. All right. So before we continue with the lecture, any questions? Yes, or questions about officer. So for this week, I'm still finalizing my schedule, but I'll post the announcement probably later tonight for this week's offer, which will likely be Friday at 1. Okay. But depending on my other meeting schedule, I may need to shift it a little bit. But my plan is to have like one office hour that's actually 2 office hour sessions. One is open to everybody, another one I will try to be online because we do have quite a few students from the distance learning section. So there will be one like a physical office hour, another one is online. Okay. But I will post for this week. I'll post the announcement with the time. Okay. Any other questions? We good? All right, I'm seeing that already there were discussions on our Moodle project forum, so that's great. Like people are starting to think about their project and trying to find classmates. So one thing I do want to emphasize, I already emphasized a few times already, make sure you have access to data. Okay, so for whatever problem you're trying to work on, okay, just do a little bit of search online. Either, of course, best case, they already have the data set. Okay? But many times, depending on your specific interest or the kind of problem you're trying to address, search online so that you have some understanding or some confidence that you can get the data. Okay, that's very important because, as I said, we've had instances where students would like to work on very interesting project, but turns out the data was really hard to get. Okay, so make sure that you search ahead of time and grab the data you need before you decide on a particular project. Okay. Question?
If we have a group, do we need to send you an email with all our group members?
All right, so the questions are, if I have a group, do you need to notify me? Okay, so generally with 3 or 4 group members, I'm fine. But for our, so we plan to do our proposal in week 7. So that is, before that, I will be asking each team to announce your project at our project forum. Okay, so that basically sending message with, say, who are on the team, which section so you belong, so that I know whether you're in the undergrad section or the graduate section, and then a brief discussion of the project. But that's something that'll be due the week before the 7th week. Okay.
And another question about when we get a project, do we need to email you what the project is to see if it's actually a data project?
Yeah, so the question that should each team be discussing with me about your project ideas? That's always encouraging. I said once I set my office hour, feel free to drop by or just send me an email, and I'll try to respond as quickly as I can. We do have a large class, but and another thing I may want to do is that as I see your comments, because right now you're still forming ideas, but as you have ideas, if you're comfortable with it, you can post it to the project forum and reply. That way others can see. If you feel that's okay with you and maybe beneficial for the class, you can do that. Okay? And I'll try to you could just say, this is what I would like to do, please comment. So you can get comment from me and maybe your classmates as well. They may point you to some good tools or even other data sets that can be leveraged. So I definitely encourage that. Other questions? How many of you are already thinking about your project? How many of you have a team, almost a complete team? A few? Okay, so then I definitely encourage you, like say, like go to our Moodle website, go to the project forum, post a message. Okay, just say I'm looking for somebody to work on a project, or this is my idea, or I'm open to any ideas, but this is generally what I'm interested in or what I'm good at. Okay, because if you're looking for people, like say I'm really good at like Python programming, or I have used this this library before, and I'm kind of experiencing this term. That always helps, like for people to kind of like team up with you. Okay.
Is there any recommended size for the data set to be used?
Okay, all right. So that's asking about the size of the data set. That question is kind of tricky. So I don't want to give an absolute number, okay? But I will say if you only have a few thousand data points in your data set, that's too small. I'm generally looking at probably in the scale of millions. Okay, so this is about like what kind of data point, like how many data points, how many unit objects you may be considering. So millions is a good number, so that means you can actually learn something useful. Okay, and feel free to go bigger. But when you are considering working with a bigger data set, my first suggestion, you don't start with your job with the whole data set. Okay, it may seem a very simple suggestion, but a lot of students have run into that kind of like trouble, because you say, I want to see how my clustering algorithm works with my data set. So you start the process, and it takes like say 1 day or 2 days, and nothing's happening. That doesn't mean the code is incorrect or what. It's because it's too big a data set, right? So just like keep in mind that if you have large data set, start with a medium-sized sample. Okay, so a sample of the data set, a subset that's medium size, meaning that actually is something you can see the results in, say, half hour tops. Okay, you may even start with even smaller one when you're just like writing a code and kind of like just playing with it, right? Because apparently you want to make sure that your code is correct and you're getting meaningful results before you want to start a much larger job. Okay, any other questions? All right, okay, so let's continue with our lecture. Okay, so first a quick review. So we finished the first chapter. Okay, this is just an introduction to data mining. So what do we mean by data mining? What are the key things? Okay, starting point is about the whole process, right? So we say that when you do data mining for your project, similarly, you start with understanding your data, or grab the data, of course. Like get your data, so you have them like physically available, and then you need to understand your data or prepare your data in some way. Right, because most of the data set, like when you just get it, it's in some kind of form that may or may not be readily suitable for what you intend to do for your project, right? So you need to be able to really kind of understand your data set, play with it, identify which features may be most useful. You may need to integrate multiple data sets, so that means that you need some kind of like identifying to allow you to correlate, right? Or merge multiple data sets, okay? Also, you want to consider any potential quality issues with your data, right? So you may need to fix your data set, or like remove the ones that are like incorrect entries or missing entries, right? Okay, so with all that, now you have a data, and you have some way of managing your data, so it's easily like accessible. And then you're talking about running your data mining tasks, right? Okay, so this depends on your specific project and what kind of things you are trying to learn from your data, that you may be using different tools, okay? So as I mentioned, like I encourage everybody to look for readily available tools. There are a lot of tools, okay? So you don't need to rewrite your own, say, K-nearest neighbor or neural network, or like a support vector machine, like tools, right? But if you are trying to kind of modify or improve that, of course, by all means, you might get open source code so that you can modify, like based on what's already available. But the idea of being able to apply readily available tools or modify it in a way such that that can be used for a project is important. Okay, that's also the key value of your process, because your capability is about being able to apply data mining techniques to a real problem, right? So understanding which tools are available, which tools have what kind of capabilities, which tools are most suitable for your kind of jobs, and what may be needed as a modification to enable something you're trying to do. These are all important skills, right? So think about like what you can leverage as like already available outside there is important, okay? And then we'll talk about the different views of data mining. Okay, so this, again, I'm putting into the context of defining your project, right? So if you want to start define your project, you need to tell me what data you're working with, right? What kind of data are you talking about, okay? And then, so with the data, say, okay, what knowledge or what things you're trying to learn or answer from your data. Okay, so these are the kind of questions. You can have a pretty long list, or like each team member could come up with a separate list of things, right? But that also then gives you some idea about what you can do with your data, right? So, and then you have already like a list of tasks, and that actually be easily like distributed among the team members, right? Because different people have different capabilities and may be interested in answering different questions, right? Okay, so with that, of course, the next question is about what kind of method, right? How do you learn the kind of knowledge you're trying to learn using whatever techniques, right? Okay, so that then requires some understanding of the specific techniques. Okay, so one question I typically get is that this is only the second week of the class, right? I'm trying to learn like all the data mining techniques that will be covered in this course. How do I like decide on like what method to use, right? Okay, so that's why we're doing the proposal thing, because the proposal is really like about, so by the proposal stage, your ideas will be more concrete in terms of what data and what like you would like to learn or how you're going to evaluate. The specific techniques may take a little bit more time, but that is fine, right? That's the learning process, because you're trying to figure out like what you can like accomplish with certain technique, but at least you know your problem formulation, right? Okay, the one way to look at this is that you have black box. The black box is the techniques you're trying to implement to answer certain questions, but at least you should understand the questions, right? The data, the problems, and then the output. Output meaning that how you evaluate, right? Okay, so view it in that way. So, and also another question is that you really need to like consider a particular data set or particular problem setting to come up with that questions. Because if you feel that, oh, I don't know how to start, right? I don't know, they're just like, yeah, data mining project, but what does it mean, right? So think about something that you're really interested in, and there's some kind of data there, okay? And then you can start asking yourself, and also, of course, that's why I say having team members and kind of really do this kind of brainstorming session is really useful. Because you say, okay, yeah, what do I learn? Like, what do I want to learn from this my data set? Then you have your list, and with that, you can like make it more concrete, okay? All right, and then we're talking about like how you define the interestedness, right? Because by depending on the specific applications, the kind of the patterns you find may be interesting or not, or may not be as useful, right? Okay, so you're thinking about whether the knowledge or the new insights, right? Your gain, of course, I'll say is non-trivial, so it's significant enough, right? Okay, previous unknown. It's not like something that's like people already like common knowledge, right? Or like it is, and also it's useful, right? Meaning that it can be applied in some kind of real world settings, okay? Another aspect we mentioned is that whether you can explain your patterns, right? Okay, so you don't just say, this is what I like, with many of the scenarios, we use data, we say this is what we observe from the data, okay? And we also see today is that like, whatever you observe, that's what you can see, but the underlying reason may not be easy to discover, okay? And then we'll talk about the major issue with data mining is about what kind of data. So you're dealing with diverse data sets, right? You're dealing with usually larger scale data. So efficiency, scalability is important, and also being able to integrate domain knowledge or neural knowledge you have acquired, right? So that's a continuous and iterative process, right? And also finally is that, I mentioned this already, is about the privacy or the social impact. Right, so if you're trying to do some kind of data analysis, like pay attention to the privacy, okay? Because through, this goes like from two perspectives. One, if you are disclosing some data online, okay, right? So you and with your data mining like knowledge, you may be able to at least have some notion about what people can discover about me. You say, I never discovered, like, I never gave like people my phone number, or I never gave people my a GPS locations, right? But then maybe from some other thing, if they know that you checked in at a particular point, or like just say like you purchased something at a particular site, right? So there are just various ways to combine multiple sources of data to learn something private or sensitive about the user, right? So just one is that as the user, like say, well, let's say you don't want to, what you want to protect, what you don't want to disclose. Okay. From the other side, as the person who's doing a data mining job, right, you want to be careful about what you disclose to the public, right? Okay. So today we're going to start with the chapter 2. Okay. So getting to know your data. Right? So this is again the stage about, yeah, I already have a set of data that I'm like, so my manager gave me to do some job, or say I found this nice like data set, or I need to find some data set that would like serve a particular data mining purpose, right? Okay, so before you do anything, okay, so this is a really say, you want to ask your question about what is my data set, right? What do I have in my data set? Okay, what kind of like properties, what kind of characteristics like I have? So there's like before anything happens, right? You get the raw data, ask those questions before you move forward. So specifically, we'll start by talking about what do we mean by data objects, so like what kind of attributes are we talking about, and then we'll be talking about like some of the statistical descriptions. So this is just like general description, right? General properties of your data set. And then briefly we'll talk about visualization and also like how we measure similarity and dissimilarity, okay? So starting point, we already said that there are various types of data. Right. So if you're giving a data set, then you can say, is your data set like say transactional data set, right? Or like is this a text data, or multimedia data, or this is a like spatial temporal data, or like this is stream data or graph data, right? So there are all kinds of descriptions that can be associated with the kind of data you have. Okay. So to start by thinking the different types of data you have. Okay. So and also we're saying the structured, unstructured, semi-structured. Okay, so let's see, like try a few examples. Okay, so if I'm giving you all the tweets, so like I'm giving you all the tweets that have been posted like in Bodo, okay, for the past week. So what kind of information do you have there?
Unstructured.
It's unstructured because the tweet itself is a free text. Any other information do you get?
Time series, you probably have a timestamp associated with the tweet.
Yes, so I usually can get the timestamp because usually when the post is posted, I have the stamp about that particular message. What else? Yes.
Be multimedia, if people are sharing pictures or videos through their tweets.
Okay, so the counters like could we get multimedia? So by tweets themselves they don't, but sometimes they provide like URLs, right? Tiny URL, then you can actually link to some other like like images or like video. Yes, potentially. There was other.
Local events.
Local events, in what sense?
For example, if there's a big concert going on in Boulder, then people will tweet about it.
Right. So then from the data or the raw data perspective, I don't know whether this is a local event. I know is hashtags, right? People may have been using hashtags to kind of like associate this particular tweet to a particular event that's maybe happening.
Geolocational data?
Geolocations. So for those of you who may have looked at the tweets a little bit, like you can associate geotags, meaning that like where you are when you posted that particular tweet. Okay, but also notice that actually a lot of tweets do not have geotags, even though that is enabled. Okay, so if you want to do any like a geospatial analysis of tweets, check your data set and figure out what percentage of the tweets actually have geotags. All right? Okay, anything else? Language in terms of, is it English or other? Okay, right. So it could be like if you're trying, but here I mentioned Bodo, so hopefully it's all English. But if you're trying to search something globally, it's likely that you may get like a different language. Anything else?
I guess graph data, right? You have a username associated with it, so you could figure out who's talking to who.
Right. So potentially you can construct a graph data because all the tweets have, let's say, who tweeted or retweeted, right? So then you actually, and going beyond that, then you say each user has like following followers, right? So you can construct a graph, okay? Anything else?
Is visible data like is publicly or into friends? Maybe it's posted publicly or into friends of friends like. Maybe it's type of graph like.
Right. So I think your comments relate to the early ones that like not only just one step, right? You could potentially, it's because you have friends of friends, so you can have multiple hops, right? With Twitter, most of the data are public. It's true that you can, using the Twitter API, you can grab a lot of the graph information. Any other things? I think we have good coverage. So one other thing I was thinking, if, like, again, depending on what you're trying to do, so the retweeting behavior actually gives you a thread, okay, or some kind of propagation. So if you're trying to figure out how things spread in this network, right, or which users are influential, or like when you actually see this kind of spike because somebody retweeted this, right? So that's also something you can learn. But that the raw data comes from the fact that you can potentially link the same tweets based on the retweet thread. Okay, so as you can see, like giving the same type of data, you can already ask like various questions. You may not need all the information, but that at least like have a good understanding will allow you to ask a question that are more interesting. Okay, let me use another example, not social network. What will be the next one? Anybody give you a topic or a data set? Sports. I see some discussion about sports-related data. Okay, so with sports data, what generally do you have? You're talking about, you probably have teams, you have players, right?
Scores.
Scores, okay. So like for a particular match, you know when it happened, like which two teams were playing and which players were playing. You can probably even know their specific positions depending on what kind of sports you're talking about. And you have the scores. The score could be more detailed, right? So you can say like when which particular score was like made. Anything else?
Which player scored?
Which player?
Like football, you could say how many yards the quarterback was able to gain, or like.
Right, so football, you could say for each particular play, right? You could say how many yards were gained, or like a backward, or penalties, or whatever. So you could have very detailed, like play-by-play type of information about a particular game or team.
You can have season-wide information from.
Sorry, I didn't hear.
You can have season information from previous games leading up to it.
Right, right. So, like a single, depending on, again, which sports you're looking at, but many sports actually have historical data, right, covering seasons or previous years or even the play across many, many matches.
You can do like temperature or wind during that.
Temperature or wind, yes. Also, this kind of information, it may not be in the exact, like say, the particular data set, but that's actually a very good example of how you can integrate with other data sets, right? You can get all the weather information, because apparently that may play a big role in terms of like the specific match, right, and where it is.
Player injuries?
I'm sorry? Sorry, somebody.
Player injuries?
Player injuries. I'm not sure that is available though, like with most data set. Like where do you expect to get this kind of data set?
You can get
News articles,
just
maybe?
general reports.
General reports.
Yeah.
Okay, all right. So apparently, like, say, if you're interested in, or like, say, you say how the performance may be affected, or like, say, the impacted by an injury, or even just figure out like the injury rate, right? How, like, what kind of injuries I see with my players, or that kind of things. That's actually another very interesting point. Okay. Other points? Other things you think can be associated with?
Rate of like new records has broken on. Rate of new records have been broken. These things.
Sorry, I'm not hearing.
Rate of like new records have been broken, established. Like someone player has done something.
New records. Okay. All right.
Salaries of the players.
I'm sorry.
Salaries. How much?
Salaries of the players. Yes. Yes. I think that is available somewhere. Yes. Okay. All right. So as you can see, like already, like we're covering different aspects, right? We're talking about sports data, but like there are all aspects you can potentially like get, and of course check data availability, right? There may be different sources for you to get, and also I want to just mention another thing. When we talk about sports, like for example Twitter, this kind of like online forum is actually also very useful for opinion analysis, right? And sometimes you kind of just based on the tweets, like you can figure out like whether this is support like for or against this team or something, all right? Okay, so these are just two examples, but hopefully like, you get the idea, right? So when you have a data set, or even let's say before you look at the specific data set, you want to ask yourself questions about what will be in the data set. Okay, so some of the important characteristics, okay, dimensionality. Dimensionality means that how many features are we talking about, right? Because here, if you're talking about a specific tweet, right? So the tweet I said like have a timestamp, a geotag, it has the actual text, that it has like the poster, or it has the hashtags associated with it, or whatever information you may get, right? Okay, and similarly for each play, like or each game, you could have a few like different descriptions. Okay, so understanding the dimensionality is important because that gives you a notion of how. One, just how comprehensive your data set is. But the other one, as I'm writing here, is about the cursor dimensionality. Okay, as we will see throughout this course, many algorithms do not work well with high dimensionality. Because the complexity just increases like significantly, because we're talking about exponential increase. Okay, whenever you're adding a new dimension, that actually kind of add in more complexity, and your algorithm may not be able to handle high dimensional data. Okay, and then it is necessary for you to do some kind of feature selection, right? Meaning that you don't need to throw in everything, right? Instead, you may want to pick the ones that are most informative. Okay, sparsity. This is about your data set. When you look at this, you expect to have everything, right? I mentioned earlier, let's say the geotags, right? So earlier, I think the Twitter, at least the data set we look at, we were looking at about 10% like tweets that are actually geotagged. Okay, that's a fairly small number if you think about if you want to do some kind of geospatial analysis, right? And also the fact that only presence counts. Okay, so this is particular like important if you're doing some kind of say opinion analysis, right? So who would write a review, either bad or good, right? So you for this particular say product, right? So a lot of customers bought this product, okay, but a very small percentage would actually write a review, okay? So do you expect the reviews you actually get is a good representation of the general view? Yes or no? Intuitively?
No.
If I'm feeling just okay, or like I don't really feel too strongly about it, I probably don't write a review, right? So I write a review if I really like it and I really want others to know, right? That's one case. Or I really hate it, right? I had a very bad experience with this product and I want people to know. So you tend to see this kind of more exaggerated more. And also, of course, if there are any paid, like solicited reviews, right? So then again, that may change. So there's just always just like understanding whether your data set is a good representative sample and what could be missing in your data set, right? Resolution, okay, so that also, again, like I say, this is related to the scale of the problem. Like, for example, like if I'm only looking at a few, like 100 or 1,000 points, it's probably one not big enough to generalize, right, to a more like representative set. Or if you say, if my like temporal resolution is say every day, it's probably not sufficient to give me like more like say like hourly or minute level information. Okay, so then the resolution really comes into the scale, but also the like spatial temporal resolution or like anything that's more specific than like regarding particular like object. And the distribution generally. So if you have like usually you have a like set of objects, right? So you generally want to have some notion of centrality versus dispersion. So as we will cover a little more here later. So think about your data set as containing a list of objects, okay? So your data set say have n objects. Say this could be 1 million, 1 billion, 10,000, or whatever. So that's the number of objects you have. And then each object will be represented by a set of attributes, right? So these are the columns if you want to view it as a table, right? Okay. So you have a table with objects, and you have each individual column to a specific like attribute. Okay. So if you're talking about a student, apparently I will ask question about what's your major, right? Which year are you in? And let's see, and then like which courses you have taken before? What are your grades or something, right? And then, so with that, of course, let's say, with each object, you want to have some way to identify this object, right? I'm asking for your student ID when you submit your work. That's how I can like uniquely identify each individual person, right? Or product ID, customer ID. So all these things are ways to kind of identify the objects, okay? And then the attributes, right? That can be different. Because depending on what attribute you're considering, this can be numerical, categorical, this can be binary attribute, right? So if you're asking gender, apparently it's a binary, right? If you're asking age, right, it's a numerical value. Or I'm asking about the price, that's also a numerical value. And if you're talking about temperature, wind speed, and all those kind of things, or stock price, right? Those can be, again, numerical values. Okay, so here just specifically, like we know that like categorical or nominal, these are just like a finite or small number of potential like names, right? So it could be like say your individual name, or like so the color, right? Hair color, that's also like a fixed number of notions. Also talking about a major, right? And also if you're talking about a binary, which is generally just yes or no, right? But it could be like, say, this person a smoker or not, whether this person has cancer or not, or like, say, gender, right? And whether, say, you're like, let's say, in my undergraduate section, like, or the graduate section, right? These are all like binary values. And the other ones are nominal, but they have some kind of ordering associated with it, right? So I'm currently associate professor, right? So if you look at the professional ranks, right, so there were like, say, assistant professor and the full professors on top of it. And if you're talking about the degree, right, we all finish high school, then college degree, and some of you may consider a master's degree or a PhD degree. So that's, again, just naturally there's some kind of ranking, right, or order in the different attribute values. And of course, numerical values, right? That's actually widely used, or actually a lot of data you'll be dealing with, they have numerical like attributes. Okay, so with numerical attributes, there are actually a lot of more details we want to cover. So one is the interval scale, right? So you're talking about temperature, right? 30 degree versus a 40 degree or 20 degrees. So the difference is 10 degrees, right? Okay, and also if say this year, next year, or this month, next month, so there's this fixed interval between those values. Okay, while others are more like a ratio scale. So that means you have a true 0 point, right? So if my income is like say 0, right? So 0 is absolute 0 because I don't have make anything. While if it's 1,000 versus 2,000, so I mean 2,000 is 2 times whatever I'm earning as 1,000, right? Okay, because this may not be true as you can see. Like the year 2000 or year 3000, that doesn't mean that the year 3000 is like 1.5 times year 2000, right? Okay, so these are just like basic properties in your attribute, and it's actually important to make those distinguish. Okay, and then finally, with numerical data, we always ask this question like, can we handle continuous values or do we have like discrete values, right? So if you talk about age, we just care about, like, say, 1, 2, 3, 4. We don't follow 1.35, right? But if you're talking about a temperature or you're talking about a stock price, you do care about the small, like, say, digital, like, say, the like real values. Okay. So again, these are it's important to understand what features is there, but also with that, when you're trying to pick a particular technique, you need to know whether your technique handles, like say numerical data or not. Does it handle binary information? Does it handle like a continuous value versus discrete values, right? That's all important for you to understand your data and be able to pick techniques that actually work for your data. Okay, so next let's look at some really just understanding the general distribution of your data set. Okay, so to start with, so say if I'm trying to get some information about say temperature. Okay, so say let's look at all the temperature readings like throughout the year. Okay, so then I'll ask the question: what's the norm? So that's that. What like typically, what do you like tend to see? Maybe say let's say just say January. Any guess? I know we're in a location where we have very dynamic weather, so it's a little bit hard to say average, but average is typically used to represent the like say what's the normal case, right? And then you tend to like can start talking about the dispersion. Okay, so here my example, right? So I have wind speed, number of Facebook friends, or temperature readings, or the age, or the annual income of my customers, or the price of a particular product, or the stock price, right? So you have like different value. Again, here when we talk about the statistical distribution, we are talking about numerical values, okay? But you could apply similarly to other category values. For example, like majority of my students are from computer science. Well, that's fine, right? So that's more like frequency based, okay? So give me any data set. So assuming you have a list of objects and you have done their description as some kind of numerical attribute, okay? Starting point, I can ask n. Well, n is the number of objects, right? So let's just say how many objects do you have, like how many students do you have, or how many sampling points you have, or how many tweets do you get, right? That's the size of your data set. And the min, max generally just give you the range, right? So what's the smallest value, what is the maximum value, okay? And then within that, we'll be looking at the centrality, right? Or actually the central tendency. So that basically says that what's the normal case, right? What's the regular, or like what's expected values. So we were talking in the other one, dispersion, really just say what are the different or the extreme or the scale of dispersion, okay? So mean, so this is the, well, you probably are very familiar with this notion, right? So whatever you, like giving a number of like n different numerical values, you can take the mean, which is if you sum everything up and divide it by n, right? Okay, that's very useful as a like a notion to figure out, for example, what's the middle point, if you view it that way, okay? And also sometimes, depending on specific data set, you may need to modify this calculation a little bit, right? So you may say, I want to do weighted, average. So that means I'm actually associating different ways to different data points. Okay, that may be useful and may be required at certain scenarios. For example, if I trust one sample more than the others, right? So if I have, like, say, air quality samples coming from multiple sensors, and I know those sensors are usually more accurate, so I may want to apply a higher weight for those ones, okay? So that's one scenario, right? Or say, if you know that your sensor could have errors, right? So then you may want to ask, like, before you do this average, you actually remove the extreme cases. Right, so you check out the check the extreme values and remove the ones that are apparently incorrect, right? So then you do your average. So these are all the things you may need to look out for when you're trying to just do a quick analysis of your data, right? Okay, median, right? Related to that, but here instead of calculating the average, you kind of sort everybody and pick the middle point, right? Okay, so median is usually more robust in terms of the extreme values, right? Because you could have extreme values at the either end, but if you look at the median, that's usually a good representation about what's the norm in your case, your sample. Mode, this is usually generally refers to the frequency, right? Well, actually, what's the most frequent value you see? Okay. Again, like if I'm assigning A, B, C, D grades to my class, then you can say, of course, what's the mode? Expect to be B, hopefully, or some class may have A, right? So that's to say, what's the most frequent value for your particular data set? Okay. And then given that the mid-range, so that's the average of the mean and the max, right? Remember, mean is the smallest value, max value. So if you take a mean and a max, take the middle point. That's the another way to estimate the average. So if you're considering, say, again, annual income, right? I take the smallest one, I take the larger one, I pick the middle point, okay? Or I can add up everything together and compute the average. Okay, as you can see, these are just different ways of computing your average, but the normal cases, right? But all of this give you a good notion of what's the general values you tend to see with your data set. Okay, and then when we talk about the dispersion, so that means does everybody get A in my class, or I have A, but I have go all the way to say C and D, or it's just A and B, right? So that's a kind of spread you want to understand with a particular data set, right? And then similarly, again, using the annual income as a value. So you could say, do all the customers or all the people I'm looking at, they have a fairly similar income, or there's a wide spread in terms of say their actual income, right? So some way to evaluate the dispersion, right? So range. Apparently, do you have a range that's fairly tight, or it's spread out, right? Okay, so the range gives you a good understanding of the scope, right? And then quartiles. Okay, so these are, let's say, quartile basically means that if you sort everybody and you look at, say, the first quartile, second quartile, and so this really 25th percentile, 50th percentile, 75%, or 90%, depending on. So the quartiles give you actually a good way to look at a sorted set, right? And then look at the corresponding value at a specific points. Related to that is the interquartile range. Okay, remember we mentioned earlier that you could have extreme values, right? So if you just pick the mean and the max, you may be looking at a too big spread. Okay, instead you may want to say, let's look at the so the Q3, Q1. So this basically covering the middle half. Right? This is the 25th percentile to the 75th percentile. So that's hopefully is the kind of majority, right? So it's not as big as a whole data set, but it is actually capturing a good portion of the normal cases. So that'll give you a good estimation of not only the middle point, which is Q2, right? But also a nice spread. So the majority of your data set would fall within the IQR. Right? So with that, then say one very useful notion is usually called this 5-number summary. Okay, so if you think about it, this number gives me in order. So I have mean on this side, max on the other side. I have Q1 and Q3, and then I have the middle point. Right? So that'll basically give you a good notion of the spread. Okay. The outliers. Okay. So in many scenarios, it's actually useful for you to separate the outliers. right? So you don't just take the whole set, average it out, and then you get your values. Instead of say, I want to look at the distribution, and many times if you see outliers, okay, as we said, there can be errors, right? So your sensor just kind of broke down, so it's reporting like just the absolute, like obviously wrong values, or could it be, say, just extreme cases, right? So if you're talking about, say, the number of tweets you are getting every hour, okay? So if you say, look at the number, suddenly you see like big change, right? So that's an outlier. So it's way different from whatever you have seen before, but that could be an indication that something is like happening and everybody is like suddenly like paying attention to this particular thing, right? Okay, so so it's usually fairly useful for you to separate the outliers and actually then examine that further. Okay, then variance standard deviation. So these are like basic like statistical measures to understand the dispersion. Okay, so next we're just talking about some way to visualize like your data. Okay, so of course, like we already mentioned that you can do all the calculations and the values or some set of values would give you a notion. But many times, some quick visualization would be very informative, right? Okay, we look at the Google Trends, if you remember, right? So if I can just visualize how things are changing like over time, that's actually much more informative than reading out the individual like values. Question?
Sorry, maybe I missed it, but what's IQR?
IQR is the interquartile range. So that's the Q3 and the minus Q1.
Okay.
So let's go back.
Quarter 3 minus quarter 1.
Right. So here, if you say like basically like we define the Q1, Q2, Q3,
Oh,
right?
I see.
Okay. So the interquartile is really the middle portion. It still covers the 50% of your data points, but that's the middle 50, like middle half. Okay, so box plot is very useful, actually fairly informative to give you a quick view of your data set. Okay, so with a box plot, we're showing actually a few things, right? So we have the Q1, Q3, which is again 25th percentile, 75th percentile, right? And then we have, so M, which is the, I think it's the mean on, that should be median. No, I think it's the mean. And then the IQR, right? So if you look at this box plot, then you have this box, right? So the 1, 2, 3. So these 3 levels kind of correspond to Q1, M, and Q3, and you have this range. And then beyond that, you can actually also draw out your min max, okay? And also, we're using this 1.5 times IQR as some kind of threshold to define like outliers, okay? Because if you don't have like significant outliers, what you can show is that you just have this min and the max value, right? But in this case, by using 1.5 IQ, I say this is still considered like not too far from the middle point portion, but you have these individual points. These are individual outliers. So that means they are way outside, okay? So we're using 1.5 IQR above and below my range here. Right, so anything like above or below, that's fine. So here, this is actually actual mean, right? So that's a minimal value, okay? But here, I have extreme cases. So this is a 1.5 IQR. And anything beyond that would be the individual outliers I'm trying to show, okay? While the others I can see, they don't really have like outliers because this is the actual mean and the max, okay? So this is just a way to quickly visualize the distribution and able to like identify the, as we said, the centrality, like so the central tendency and also the dispersion of your your distribution. And then the other one, consider the normal distribution. Okay, so we have done this calculation before. So with a normal distribution, right, this is the shape. And also generally we look at the, like, see the like standard deviation, right? So it is like one, like minus or plus, like one standard deviation. So the middle point is the mean, right? So you look at to the left and right, one standard deviation, we're covering 68%, right? And then if you go like over to the 2 standard deviation, then it's like 95, and then all the way to the third one is 99.7, right? So as you can see, so depending on how wide you go. Do you go like 1 standard deviation, 2 standard deviation, 3 standard deviation? Okay, but that's a way to capture a majority of your data set. So the extreme values will be easy to identify because they're way outside your distribution, right? Or the range of a distribution you're looking at right now. And the other related example, so this is called a cone type plot. Okay, So contact, again, same thing, right? You kind of sort your data, then you look at it, like, say, you look at a 10th percentile, 20th percentile, and all the way to, like usually people ask about, say, 95 percentile, right, or 90th percentile, okay? So again, this is a good way to separate, right? So you're really kind of marking a few points along your sorted value so that you capture the represented points, okay, along within your distribution, and then you actually can easily identify the extreme values, okay? So if you're saying, like, you're looking at, again, annual income, right? You could say, like, so 90% of my, the users actually have, say, at least, say, 50K per year, okay? So that's one way to look at this, okay? Or if you think about, say, my class, right? If I'm giving out the grades, right? So you can say, like 10% of people are actually above certain, no, that's another way to. So if we say there are 10% of people in my class actually got C or worse, okay, that's another way to look at the distribution, right? So basically you want to say, if I have a class of, say, 100 students, right, I rank their score, and I'm picking out the data points to figure out where they are at. Okay, and then you can, like, of course, like, set your, like, thresholds for different grades. So that's another way, just kind of to visualize, but also determine the distribution of your class, data set. Another one related to the contact plot is called QQ plot, or contact plot. Okay, so this is actually a way to kind of say compare, like, two different values. So in this particular example, right, so I may have like a retail company may have 2 branches, okay? And I'm trying to look at the unit price. So that means the products that are being sold at a different branch, okay? Because, like, sometimes depending on the location or depending on the purchasing capabilities of my local customers, right? Like different products may sell better at different places, right? Okay. So in this case, I basically compute the quantiles for, say, the branch 1, so with all the product prices, and the branch 2, and also compute the percentile, okay? And then I draw this as X and Y axis, okay? So if I see the points that align perfectly along this diagonal line, what does it mean? They have the same distribution, right? So that means the middle price for branch 1 is also the middle price for branch 2, right? And the middle price, say, another middle, say, the 75th percentile price for one branch is also the same. So that means the 2 branches, right, have similar distribution in terms of product price, okay? But if I see something that's above this, if the points like this one's showing, right, the points are here, what does it mean? So this is the median, right? Okay. So basically what is showing here is that, what is the median? Oh, yeah. So the median price, so that means if you look at down here, so that means somewhere below $80, right, is for branch 1. And actually for branch 2, the median price is higher. What does that mean? So generally, if you see points above the line, so that basically says that the branch 2 actually has products that are slightly more expensive than the branch 1. Okay? Right, so of course, like for this, like you may need to read into this a little bit, but I think generally this will give you a good way to compare 2 distributions, right? Okay? All right, this one, hopefully, I think we're all familiar with. Okay, so generally referred to as the histograms. Okay, so this is generally useful when you're trying to like look at a distribution and then kind of bin them. You put them into different buckets, right? So you split your range into multiple buckets, okay, and then you count the frequency, right, of the values like for each bucket. Okay, so this is a diagram showing, I think this is, the age distribution. Back in 2011, this is the social network, the users of social network, right? And then you're trying to figure out like the age groups of your like users, okay? So as we can see in this diagram, we see that apparently the middle age, or 45 to 54, that's actually the highest portion, right? You can see, and the actually interest that people in 35, 44 are actually lower. And then the younger generation here, they tend to be a bigger portion. And it's interesting to see that there's still quite a few people who are older, like these are more like grandparents. They want to connect with their like grandchildren, that kind of thing, right? So again, this is a fairly like straightforward way to visualize a distribution, okay? Of course, like say, there are some specific decisions to be made about how you split your buckets, right? Because depending on how you split the buckets, you may or may not like see particular patterns, right? So if your buckets are like too big, or actually crossing two fairly different groups, right? Then you may not see the pattern like as significant. The last one, so this is scatter plot. Okay, so scatter plot is really like plotting the dots, right? So you can see. So basically, you have like two values, x and y, right? So you're showing like whether one dimension is correlated with another dimension, right? Let's say, is age correlated with the annual income? Maybe. You expect that to be, right? Or like, is the product price correlated with the sales, like the actual sales number, okay? But generally, with this kind of like plot, so you're plotting one attribute here and another attribute here. So if you see this kind of upward like trend, what does it mean? Think about age and annual income. If I'm giving you this plot for like age versus annual income, what does it mean?
Higher the age, greater the annual income.
Sorry?
Higher the age, greater the annual income. Something like that.
Okay, I'm not sure I'm getting that. So basically, if I'm showing if age is x-axis and y is annual income, if I'm see this, what does it mean?
Positive correlation. Yeah.
Positive correlation meaning that as you become older, you make more money, right? So that's one way to explain it, right? So that's the positive correlation we're seeing, okay? And then if I'm showing you this one, still it's age versus annual income. What does it mean?
In middle age, you get most.
You peak at age.
Yeah, right. So you kind of like a boost, like you increase your annual income as you become more experienced, right? But at some point, like as you become older, your salary kind of decreases. Hopefully that's not the case, but again, that's one pattern you can potentially like learn from your data by plotting this kind of scatter plots. Okay, and this one is a downward, right? So downward, I don't have a good number, good example for this. Will it be a negative correlation? Oh yeah, so one way is that the number of people who use Facebook versus the number of people who use, let's say, Twitter. Okay, assuming these two are competing, right? So that means as I have more users kind of switch to Twitter, that may actually see a downward trend for the number of users who actually are using Facebook, okay? Or I say like Home Depot and Lowe's, right? These are two generally competing places. So if people are going to, like more people are going to Home Depot, then you tend to see a downward trend. Right? These are usually in these kind of competitive scenarios, okay? Again, these are random examples. I don't have data to like validate that, but this is really just a user example, okay? And of course, like I say, those ones are still scatter plots, but it's probably not easy to see any trend or like relationship here, right? But because of this visual capability, you can easily determine whether there's any like potentially hidden pattern there, right? And then you can use, of course, you can dig further to learn more. But this is actually as a first level, like learning of your data. This is actually fairly powerful. Okay, so I will spend just a little bit of time talking about visualization, but visualization actually becoming a very important aspect, right? So there is like actually a lot of research or like actual use of like data, like visual analytics. Okay, so that's actually a way of being able to augment, right, just automated data mining, like with some kind of visualization. There's also always this kind of interaction between experts and the like automated process, right? That will actually allow us to capture like more information. Okay, so with some of the, I'll just probably go with some of the examples that would give you some idea, right? So here, like each individual one is a scatter plot. Right, so I have, let me say I have 4 features or 4 attributes. I'm trying to determine whether those 4 attributes have any correlation with each other, right? So what I do, I take, so this is a 4x4 grid, okay? Each grid is one scatter plot, Okay, so this one corresponds to, say, the third attribute and the first attribute, right? This one is, say, the second attribute and the first attribute. Okay, so by looking at this, then you actually can easily determine whether there's any particular trend here. So potentially, I say my third, well, this is my second attribute, and my first attribute may have some positive correlation, while the others don't seem to be very useful. Okay, that's one, right? And another example. Okay, so these are generalized, say, if it's a 2D, like you shouldn't say it's a heat map, right? You can also draw this kind of 3D, okay? So this, again, just give you some idea, like in a particular, like 2D or 3D space, you have some way of viewing what's more, like just where your values are, right? Or how significant those values are, okay? So if you tend to see this kind of like valleys or like high mountains, right? This generally represent like how significant like some values would occur in your particular data set, okay? And this is the other one. So this is usually called a word cloud, right? So many of you may have seen this before. So if you have a data set, like remember earlier, we mentioned that like free text, right? It's not easy to see, but you could maybe visualize like a corpus of data document by just like using a word cloud. Basically is capturing the high frequency words. Right, so the size, like, or the font size of those words should represent how important it is, and also you can use color, say, to determine, like, to represent the different categories, right? So this would be like, I think this is about a news article, like word cloud. So it's basically like what's happening, right, in terms of all the news, okay? And then you can do this by different categories. So this may be sports, and this may be like global or world, and the other ones may be politics or whatever. So as you can see, this again is a way to quickly visualize your data, right? And it can give you quite informative like information regarding what's significant or what's changing.
Can you go over the first picture again of how each of those data sets?
This one?
Yes.
Okay, so the question was about the first picture. So this is just an example of using scatter plots to identify potential correlations between multiple attributes. Okay, so we mentioned earlier is that if you look at a single scatter plot, right? This is a single one, and a single scatter plot can tell me whether one attribute is correlated with another attribute or not. Okay, while here I have 4 attributes. Okay, so I want to be able to quickly determine. So of course, we're talking about this pairwise, right? Comparison to see whether any 2 attributes are related or not. Okay, so this is just a way of kind of like compiling, like this is a 4 attributes, so I have 4 by 4, like possible combinations. Okay, or actually 4 by 12 if you want to kind of ignore this one, because this basically says you're always correlated with, perfectly aligned up with your own attribute, right? But for the others, because you have this aggregated view of those scatter plots, then you can quickly have a high level and like observation of like potential correlations across different attributes. Okay? Yeah. All right, one more. So this one is actually more useful in terms of high dimensional data, right? So remember when you have multiple dimensions, right? So I have age, I have, say, a profession, I have like annual income, I have their creditors, like ratings, and many other things. Okay, so we have many dimensions. One thing is that you could just like say, now it's fairly difficult for us to draw a high dimensional like space, right? We can draw 4D, potentially 3D, right? So 3D, and then you can use color. But then so here, if you have multiple dimensions, right, usually 10 or 100 dimensions, right? So what is a way to draw this is actually this one, each line corresponds to a dimension. Okay, and then you can line up, so basically kind of like have multiple vertical lines corresponding to the dimensions, okay? And then using some kind of color range to show some kind of grouping, right? So you can say this is like a band somehow represent a subset of the data objects that are correlated, say maybe between this attribute, and then the other attribute, okay? So we're not going to detail about this kind of like plotting is generally used for like high dimensional data. Okay, so these are really just quick examples. Okay, we for this particular course we're not spending a lot of time, so this is probably the only discussion we're going to cover. We still have other like examples for visualization later on, but the course will not cover more, but I feel this is a very important aspect. And like, if you're interested, you can, of course, read up more on like visual analytics, or for your project, consider like some rich visualization capabilities, which would really allow you to like learn interesting patterns. Okay. So finally, let's talk about similarity and dissimilarity. Okay. Remember, we mentioned in the previous lecture about identifying clusters, right? So clusters generally say if you want to group some objects into one cluster, right, and other objects go to the other cluster. Okay. So the underlying notion is this similarity, right? So within clusters, you want these objects to be similar, right? And then if you have two different clusters, that means they must be different in some way. Okay? So that all relies on this fundamental notion of object similarity, right? Because each object is represented by some kind of high-dimensional space or some attributes, right? So you take one attribute here and another attribute here. So this could be two users, two products, or two samples, whatever, right? But they are represented by their attributes. So you need to define some kind of notion of similarity, right, for the attributes. Okay? And then you can determine whether they are similar or not, or whether they are far away from each other, right? Okay. So depending on your data, so one way is that I just represent like my attribute values. Okay. So this is more like the table view. Right? Remember when we said your table basically lists as like, so each row corresponds to one object, and each column corresponds to one attribute, right? So that's one matrix. Okay. So in this case, you have the raw data, right? Or you could have as your input value or this process value, which is your distance matrix, right? So in this case, you're already calculating the distance. So I don't give you the raw value, like as in the first case. Instead, I'm giving you the distance between, say, this is the second object and the first object, right? So also this is third object and the first object, okay? And here, as you can see, we have this kind of diagonal representation. We don't care about this one. Why is that? What's the assumption there?
It would be
symmetric, right? So that means the distance from A to B is the same of the distance from B to A, okay? So this is, of course, generally true for most similarity function would be considered, but I just want to point this out because when you have specific scenarios, you want to like understand how the distance function is being defined and how that may impact your calculation of similarity and later on clusters. Okay, so here are just a few examples that are like widely used as like distance function or similarity functions. Okay, so note that like when we say similarity, that's when we say how close they are, right? Distance means that how far away they are. So for similarity, the smaller the value, that means the lower similarity. For distance, smaller value meaning smaller distance and higher similarity. Okay, that's just general notion. Okay, so we have generally used the LP norm. So that could be L1, L2, or LP, depending on some value, right? So LP norm is widely used for many scenarios. Euclidean distance is used for a lot of cases, and it has been shown that it's like very useful for various types of calculations. Okay, Manhattan distance, which is L1 norm. Okay, but these are just examples. We'll actually discuss this a little bit further later. But then the key point to get is that when your distance function or similarity function plays a very important role in your calculations or in your data mining process, okay? Because a lot of the tools, for example, like say the K nearest neighbor or clustering or some other methods, they rely on a good distance function, okay? So even though, like say, when you're running some tools, most of the tools provide some standard, like list of distance functions, right? You can easily try different ones to see which one works better, okay? But sometimes having a better understanding of your data or the attribute values would allow you to define or modify distance functions that would work better in your case, okay? We also mentioned weighted distance, or actually when you do feature selection, it's a way of weighting, right? You basically assign 0 weight to the feature that you don't select, right? Or you're assigning higher weight to the feature that you think are more important, okay? So that's also, these are the different things you can play with when you're trying to So giving your specific like problem and your specific data set and your specific features, right? You always want to consider, or actually spend some time thinking about the right distance function to use, okay? All right, so they're just specific examples of Euclidean, as we're all familiar with it, but they should give you like some like difference in terms of how you calculate Euclidean distance versus Manhattan distance, right? Okay, so these are just general properties in terms of distance functions, right? Of course, you say if two objects are different, right, they should have value that's kind of like non-zero, distance value, okay? Or they're the same object, apparently they should have 0 as a distance value. And then it's like asymmetric, meaning that I and j would be the same. And also, for some scenarios, so or most scenarios, we do require, or the algorithm actually require the notion of triangle inequality, meaning that going directly from I to j would be shorter than going through another point. Okay. All right. So with that, let's actually finish this up with a little more discussion of nominal attributes. Right. So far, I've been talking about the numerical attributes. Right. We can easily compute the mean. We can compute like the distribution of the values. But then when you have a nominal attributes, right, have say major, you have age information, because age is numerical, but many times you want to kind of group them into different categories in terms of like teenagers or college students or middle age or senior, right? So with those, then first, of course, you want to say, how do I define similarity, right, of nominal values? Okay, some of those are easy, right? If you have age group, right, say maybe like, say, apparently if they're next to each other, right, if they have some kind of ordering, then it's easy. Because say the middle age, that would be closer to, say, the, like, say, the senior than the, like, a younger age group, right? But the other ones, like, say, hair color, occupation, major, right? So then I can say, like, is computer science considered closer to, I don't know, like, let's pick another one, history versus psychology? That's probably hard to define, right? So instead, we actually consider exact match, okay? So what we're looking at is that I have, say, like the I and the j, right? So they have a certain value. So we're really talking about exact match versus total number of variables, right? So both objects are being represented by a few attributes, and those attributes can be hair color, can be major, can be occupation, right? So whenever they say the one attribute value matches exactly, so I mean that they have the same hair color, they have the same occupation, and they have the same major, right? So with that, of course, it's easier for you to say, like, if there's more exact matches, okay, then there's like they're more similar, okay? The other one is use this binary representation. Okay, so like is your hair color like black? Is your hair color like blonde or like brown? Or is your major computer science? Is your major like electrical engineering or something else? Right? So when you have this binary representation, then you really have like values like this, right? And then we can then use the binary similarity calculation. So let's look at this example here. So when you have two objects, right? So the objects have binary attributes. So binary means that you can have 0 or 1 values, okay? So apparently if it's all 0, it's a true match, right? So like, so 1, 1, so that's a Q case, okay? 1, 0, so that's 1, 0. So you're basically dealing with the 3 or the 4 cases, okay? About the 2 by 2 combination of their values, binary, right? Okay, so for symmetric binary values, which we'll talk about sooner, soon. So this is the case where, say, when you consider, like, say, gender, okay? So the gender notion is that you usually have roughly half-half distribution, right? So you don't have a large, like, a portion of, say, like, male versus female. But if you're talking about a smoker versus non-smokers, okay? So it's probably expected that you will have a much higher number of people who don't smoke versus the people who actually smoke. Okay, so there actually will be a difference in terms of the distribution or the exact values of Q, R, S, T. Okay, so if it's a symmetric, we consider all the cases. So these are Q, S, T, these are all the scenarios. And then R means that that's when they're different, right? And S is other case when they're different, right? Because Q and T are the case when they match. They're both 1s or both 0s, okay? R and S correspond to the case when they don't match. Okay, so the distance function is defined by R plus S as a nominator, and then the overall value as a denominator. Okay, but when it's asymmetric, so we actually remove this t part. Okay, so t is a 0, 0 case. Okay, 0, 0 basically means that nothing's happening, right? Okay, and because of the dominating one, so usually you want to remove t because otherwise t will be dominating all the other values and you will have a small distance anyway. Okay, so one example related to this is consider the purchasing records of, say, Amazon products. Okay, so the fact that, so like for any product, okay, or actually for any user, the user would only purchase a few items, right, compared to the vast majority of the items that are available at Amazon, right? So this is already a binary case where when you say 1, so you're going to see like a much smaller number of ones for purchasing compared to zeros. Zeros mean that this item has not been purchased by that user, right? So if you're trying to compare two users based on their purchasing records, okay? So user 1 has purchased, say, 5 items. The other user has purchased 10 items, okay? And then there are, like, say, 10 million items in the store, okay? So if you consider T, which is the case that neither purchased this particular item, we're talking about 10 million, right? Okay, so now you're comparing this 5 and 10, and then with the denominator of 10 million, what do you get? It's a very small value, right? Because it's dominated by this, like, this big portion of, asymmetric values. Okay, so that's why it's always important when you're dealing with the binary values to consider whether this is symmetric or or asymmetric, because that would affect how you define your distance function. Okay, so here I'm using a quick example to show that, like, I have different attributes, I have different patients, okay, and then we need to figure out who is more similar to whom. Okay, so here I already know that the gender, I assume, is a symmetric binary variable. Okay. Running fever or not? Asymmetric, right? Like, generally we don't expect to, like, say, half people like having fever, half people not having fever, right? So this is a symmetric value. Coughing, similarly, okay? And then you run 4 different tests, and then they can be positive or negative, okay? So in this case, I'll say gender is a symmetric binary variable, and all the others are asymmetric binary variables, okay? So let's ignore gender for now, and I want to just see whether I determine Jack and Mary and Jim who is more similar to whom. Okay, so I'll skip the actual, like, detailed calculation, but you can do this later by yourself. But what I'm doing here is that really I'm comparing. Remember that I'm ignoring this T case, right? Negative, negative case. Okay, so that's why I only have 3 values to add up for the denominator, and then the 2 cases are the R and the S cases, right? 1, 0 versus 0, 1. Okay, so when I add up all this, I get values like this, right? So 0.33, 0.67, 0.75. So what's the conclusion? Which ones are more similar? It's the distance, though. I'm calculating the distance.
Jack and Mary.
So Jack and Mary with a distance 0.33, that's the smallest distance among the 3 calculations, right? So that basically means that Jack and Mary tend to be more similar given their scenarios. If you look at this, Jack and Mary both have fever, both are coughing, positive for test 1, negative for test 2, and then negative for test 4. So they only differ in 1 case, right? Okay, so that's again the general notion of, like, how you compare binary values. Okay. All right, and then I think we're almost running out of time. Okay, so I'll stop here. So this is this one. What we won't go into is actually just to summarize this one. So this is a chapter, as I said, this is really before you do anything. Okay, really get to know your data. There are different ways for you to ask a question about your raw data. Okay, and understanding what would be important in terms of attribute values and how you define similarity and distance. Okay, that's all for today. Thank you.